Hello and welcome back to another video. Today we're going to look at worksheet number 2. And we'll start with problem number 1. So problem number 1 is just matching terms to their definitions. And so the four terms that we're looking at today are function, relation, domain, and range. And we'll try to keep this video short so we won't go into too much detail, but um, let's go ahead and just go through A, B, C, and D, and so on. So A, the set of all x values in a graph. That is the domain. The set of all x values in a graph, and I'll show an example of that in just a moment. B, a relation where each element of the domain is paired with exactly one element of the range. So here we have actually the words domain and range used, so it's not going to be either of those. Uh, a relation is also used there, so it's not going to be relation either. This is a specific type of relation um, that has a special property on the elements of the domain to the range. And so this is the definition of a function. We'll give an example of a function in just a moment. And then C, the set of all output values for a function. The set of all output values is known as the range. Okay. So let's give an example of a function. How about the function, let's give f of x equals the square root of x plus 4. Okay. This is a function. Um, we can plug in a bunch of different x values. All of the x values that we can plug in are part of the domain. And so let's go ahead and try to plug a couple of them in. Let's just choose some numbers. So f of 0 is the square root of 0 plus 4. That's just the square root of 4, which is 2. And so we have the ordered pair 0, comma 2. This gives us an element of the domain, 0, and an element of the range, 2. We can try to plug in another value. Let's say f of negative 4. The square root of negative 4 plus 4 is equal to the square root of 0, and the square root of 0 is 0. So we have another ordered pair, negative 4, comma 0. And notice how each of the elements of the domain that I'm plugging in, I'll highlight them in light green. These are elements of the domain. They are getting paired with exactly one element in the range. And this is true for any value that I plug in, any value that is able to be plugged into this function, uh, will be paired with exactly one element in the range. Okay, so let's try another value. How about f of, let's see, f of 5, the square root of 5 plus 4. This is equal to the square root of 9, which is 3. So we have another ordered pair, 5, comma 3. Okay, and so we can plot these on an xy plane. Let's go ahead and draw the coordinate plane here. And this is just going to be a sketch. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we'll just do 2 in the negative. Okay, so there's our x-axis, our y-axis. And so we can plot the point, I'll graph it in blue, 0, 2, that's there. Negative 4, 0 is there. And 5, 1, 2, 3, 4, 5, comma 3. Okay, and we can plug in more values. Let's actually try to plug in one more. How about f of negative, let's do negative 5. Well, the square root of negative 5 plus 4 is equal to the square root of negative 5 plus 4 is negative 1. And the square root of negative 1 we will say is not a real number. In this class, we're not going to talk about imaginary numbers. All of our functions will be real valued functions. And so we will, essentially say, well, this is undefined for our class. It's not a real number. You may have heard that this is equal to I, and that is true. Um, but we're not going to graph I anywhere. We'll stick to real valued uh, functions in this class. So -5, since it does not get assigned to an element in the range, we're going to say that -5 is actually not part of the domain of this function. Okay, so um, we're going to get into this in a later problem, but for now, let me go ahead and show you how to find the domain of this type of function. For a radical function, we just said that we can't take the square root of a negative number. So that means that we don't want this x plus 4 to be negative. If we do not want x plus 4 to be negative, then x plus 4 must be larger than or equal to 0. And so if we solve this for x by subtracting 4 on both sides, then x is larger than or equal to -4. This is the domain of our function. X is larger than or equal to -4 would be all the numbers from -4 larger, so to positive infinity. And that is why when I tried to plug in -5 is outside of the domain. That's not going to work. -6 is not going to work. Anything to the left of -4 will not work. We could plug in larger numbers, larger than -4, and we've done that. And we plugged in 0 and +5. We could plug in even more, but for the sake of time here, I'll just remind us what this graph looks like. It looks like a half of a parabola on its side. So it looks something like this. Okay, so let's go ahead and take a look. Just to continue here with these these words that we were talking about, the function, and I'm going to use some special notation here, but the function f takes a value from, I'm going to call it a set D, the domain, and it maps it to another set called the range. Okay, and so this function f is going to take a value from the set -4 to infinity, and it's going to map that number or transform it to an element in the range, a number in the range, and the range we can see from uh, our graph is going to be the set of numbers from 0 to positive infinity. Okay. We can see the y values uh, go as low as 0, right, in the vertical direction. Y value of 0 is the lowest value that this function gets, and then it just continues to increase from there. You can see the graph increases. Okay, so the domain is -4 to infinity. We showed how to find that. The range, we should be able to identify the range by looking at the graph. That is just a set of y values that this function attains. That is 0 to infinity. We won't talk about range as deeply as domain, but we should be able to see, at least from a graph, what the range is of a given function. Okay, so good. C was the set of all output values. We can see the output values are all 0 or larger, 0 to infinity. Okay, let's continue here with our terms. D, a graph that passes the vertical line test. Oh, well, a graph that passes the vertical line test is just a function. The vertical line test, if you'll recall, is a way to tell whether or not a given graph is a function or not. And the vertical line test just says if any vertical line that is drawn intersects a graph at most one time, then that graph is a function. Okay, so if I can draw a vertical line and the vertical line crosses the graph at a maximum of one time, then that graph is a function. Okay, and we're going to get into problem number two, but let me go scroll down here. This here in part B here, or this middle graph that I'm putting the vertical line on, this is not a function because the vertical line does not cross the graph at most one time, at a maximum of one time. In this case, this vertical line here, if we extended it from, up and down forever, it would cross one, two, three, four times. And so as soon as a vertical line, any vertical line crosses a graph more than once, that is not a function. Okay, so we'll talk about number two in the next video, but just wanted to show something that is not a function. Uh, the graph in blue, the square root of x plus 4, that is a function. Okay, so we'll write here, a graph that passes the vertical line test, that is known as a function. A relation that assigns exactly one output for each input. Exactly, exactly one output. That's the same as exactly one element of the range, because the range is a set of outputs. For each input, well, that's for each element of the domain. So that's the same wording as in part B. It's just changed a little bit. It's the same meaning as in part B. We just changed the statement slightly. So this is for a function. The set of all input values for a function, the inputs that we looked at earlier, here 0, -4, 5, these values, these input values that we input into the function, these are elements of the domain. So the set of all input values is the domain. Okay, then we can move on to G, a rule which associates inputs and outputs. Okay, so a rule that associates inputs and outputs, that is what's called a relation. I am not going to get too deep into what a relation is, but a relation is just essentially a pairing of inputs and outputs, but it's not necessary for each element in the domain to be paired with exactly one element of the range for just a relation. If we want that relation to be a function, then we do have to satisfy statement B, where each element of the domain is paired with exactly one element of the range. But there are relations out there where that is not satisfied, and so those are not called functions; they're just called relations. An example of that would be this middle graph that I was talking about earlier, the one that looks like an 8. There is an association between inputs and outputs, but let's take a look at a couple of these here, a couple of these points. The input of 0 is assigned with the output 0, but 0 is also assigned to 4, and 0 is also assigned to -4. And so there, we do have still pairings of inputs and outputs, but the each element of the domain, each input is not paired with exactly one output. So this would not be a function, but it is still a relation. Okay. And then finally, the set of all y values. What do we call the y values? Well, we saw some y values earlier, 2, 0, and 3. These were all y values, and they are all part of the range. Okay, so the set of all y values is known as the range. All right, so um, let's see where we are. Yeah, let's go ahead and uh, we'll continue. Actually, just go into problem number two. I usually just do one video for one problem, but we'll go into problem number two. Just to use these terms, we're going to use function, relation, domain, and range in this next problem. And so just to kind of elaborate on them a little bit further, we'll just continue the video. So, problem number 2 says, determine whether or not the graph relations represent a function. Then determine the domain and range of each relation, writing them using interval notation. Okay, so to determine whether something is a function or not, we can use the definition of a function and see if each element of the domain or each input is paired with exactly one output. We can check that. Um, or we can use the vertical line test because we know that a graph that passes the vertical line test is a function. So if it fails the vertical line test, then it will not be a function. So let's go ahead and see. The vertical line test, I'm going to start with actually part B, or the middle one that we've already talked about, because it's a nice example of something that does not pass the vertical line test. Here is a vertical line. We only need to find a single vertical line that crosses the graph more than once, and that is enough to say that this is not a function. So here's, well, actually I'll just use, yeah, this one here. But there's a bunch of them. This vertical line here is also a vertical line that would cause this, or that would show that this is not a function. But I'll use the one at here, at x equals 0. So at x equals 0, uh, that vertical line crosses the graph 3 times, it looks like. And so since the vertical line crosses more than once, it is not a function. Now we can still find the domain and range of this relation. The domain is going to be just the set of all x values that appear, the set of all x values that appear in this graph. And so let's see what x values appear. Well, I'll choose this point here, and we're going to kind of estimate if it's unclear at all. But it looks like this function goes as far as -4 in terms of the x values. And then it has all sorts of x values as it kind of travels through its path. And the rightmost x value here is +4. Okay. So if you imagine this graph getting squished down to the x-axis, this point here would go to -4, and then all of these intermediate points would be squished down in between -4 and +4, and that would give us the domain. The domain of this relation is -4 to +4. And we will include those endpoints because there is a point whose x value is -4. -4 is included as part of the domain. That point would be -4, 1, 2, 3. I'm just going to say about -3. Right? Okay. So that's the domain. It goes, domain, you can think of it as, left to right, the x values that show up in the graph. Okay, and that's actually with the first definition, the set of all x values in a graph. So now we can actually, talk about this a little bit more if we wanted to. Don't want to go on too long, but we could ask over here at x equals 5, is x equals 5 part of the domain? Well, no, the function doesn't exist when x is equal to 5. And that vertical line does not touch, and I said function, but it's just a relation, not a function. This graph does not exist beyond the x value, x equals 4. So the domain will not go beyond x equals 4. So what about the range? Well, the range, let's see. Actually, the range uh, is the set of all y values in the graph. So let me use blue for that. We had the definition there. So the set of all y values, well, what's the lowest that this function goes? The lowest is -4. And then it kind of, I'm just going to trace the curve. The y values increase. How far up do these y values increase? They reach a maximum value of +4. So, well, the range is also going to be from -4 to +4. Okay, and including those values again because there are points who have those values uh, on the graph. Okay, so there's one. Let's try the left graph. First of all, is this a function? If I say no, I should be able to find a vertical line that crosses this graph more than once. Okay, and by the looks of it, there is no vertical line. This thing is going to increase, but it's increasing and moving to the right slightly. And so there will never be a point where a vertical line crosses this graph more than once. So this one here, we will say, yes, it is a function. Now, what is the domain of this graph? Well, actually, this does look, some of these we have to be a little bit careful with. Excuse me, because they may have vertical asymptotes, and it does look like actually this graph. So it's kind of open to interpretation. I will draw a vertical asymptote here to say that this function is getting, very close to this x equals 3, but it doesn't actually ever reach it. It can continue to get closer and closer and closer to x equals 3 by the slightest amount and continue to go in the upward direction. And, it would still be a function. So, what is its domain? Well, uh, as I mentioned, we can kind of just map all of these points to the x-axis. It looks like, and this arrow points to the left, so we're going to have an arrow pointing to the left. All of these points would be mapped down to the x-axis. And we get closer and closer to positive 3, the x value, but we don't actually ever reach it. That's what an asymptote indicates. And so I'm going to put an open circle here because we don't actually ever reach the number positive 3, but we get as close as we want to it, arbitrarily close to 3. So our domain will be negative infinity to 3, and would put a parentheses there on 3 because we don't actually ever, there is no point on the graph that has an x value of 3 because it does not reach 3. All right, so the round parentheses means we don't include that value. Okay, what's the range? Well, the range will be the y values that show up. So what's the lowest y value? That is this one here, or this point is the lowest point on the graph. It has a y value of 0. And then we can see that the graph, well, if we went this way here, the graph seems to increase up to a value of 2, and then it levels off in terms of the y values. But it also keeps increasing on the right-hand side. So we need to see what are all of the y values that show up in the graph. Well, um, the y values just increase to positive infinity. Again, if I were to, just map all of these points to the y-axis, all of the y values would highlight the y-axis forever in the positive infinite direction, or the positive direction for an infinite amount of numbers. And so the lowest point seems to be 0, 0. So 0 is included as part of the range, and it goes up to positive infinity. So that is the range. All right, let's take a look at the next one. The next one looks a little bit funny. So let's see. We'll draw a vertical line to see if it is a function first. And so if this is not a function, we have to be able to find a vertical line that crosses more than once. And this one's a little bit tricky, but what do you think here? Is it a function or not? Definitely in between the open circle and the closed circle, the vertical line only touches the graph once. So the question is, whenever one of these, open circles is above the closed circle, at those points, does the graph cross more than one point? And the answer is no. They are purposely shown to be one closed circle and one open circle, showing that the graph will cross at the open circle, and then it's not crossing, the graph will cross the closed circle, and it's not crossing the open circle. The open circle means that there is no point. We're not counting that point there as part of the graph. And so this vertical line will never touch 2 points on the graph at the same time. Okay, we could zoom in a little bit. I know it's going to be a little bit hard to see, but we're touching. Let's say here at this bottom where the little boxes The vertical line is touching this bottom one. And then once it gets to this last point here, this closed circle, as soon as I pass the closed circle, well, it's no longer touching this bottom step, but now it's, gone up and starts touching the one above it. Okay, so there is a smooth transition there. Um, so this is a function. Okay, so we will say yes for function. Now, what's the domain? Well, the domain, uh, it can be seen actually with this vertical line. Another way to see the domain is to see, well, when would a vertical line be touching the graph? We said over here, beyond x equals 4, to the right of x equals 4, this vertical line no longer touches the graph. But if we look at this one over here, well, the vertical line will always be touching the graph for the values between -4 and +4. Beyond +4, an x value of +4, it's no longer touching the graph. So the domain is going to be from -4 to +4. And we can see if, as I mentioned earlier, if we map each of these points to the x-axis, well, there we will get an open circle. And then we have a solid bar. And this closed circle can be mapped here. And then notice that the next open circle is going to be overlapping it. So there's an open circle, but the closed circle fills it in. And then this bar here, an open circle, but the closed circle, fills that in. So starting from the other side, let me start here. We have a closed circle. And then let me map this open circle down here. So it looks like there might be a gap there because of the open circle, but then when you map this closed circle down, it's in the exact same x value, it closes that gap, and so you can essentially think of this whole thing as just being solid, the domain is, continuous along the x-axis. So the domain, there is this one closed circle way on the left that doesn't get covered, so it will be -4. Because it's an open circle, we use a round parentheses, and then all the way up to +4, and that is a closed circle on the right-hand side, so we use square bracket. Now the range, what is the range? This one's a little bit trickier. Well, actually, the range is going to be if we map all of these points here to the y-axis, they all have the same y value of that would just get mapped to the same point. That would be a y value of -3. And all of these points have the same y value, so they would get mapped to the y value of -2. This point here, which the point is actually 0, -1, but the y value itself is 0. Um, all of these would get mapped to the y-axis to give us a point here at 1, 2, 3, and 4. We don't often see graphs like this, but they do exist. The range here is going to be a set of just distinct values. They're going to be just, it's not going to be a continuum of numbers like the x values were. Notice every single number from -4 to 4, not including -4, is part of the domain. But as part of the range, the output values are going to be -3, -2, -1, 0, 1, 2, 3, and 4. Okay. All right. So because you could ask, hey, does this graph ever take on a value of +2.5? And the answer is no. This function never has the value 2.5. So it would be incorrect to say that the domain is from like -3 to 4. This would be wrong because that includes the number 2.5, which this function never has as an output value. All right. That's pretty nice. And a graph that actually looks like this, that an application of this that you might come across is a phone bill. I used to have Xfinity Mobile as my carrier, and they would charge me a certain amount. It was $15 for each gigabyte of data that I used. And if I used anywhere from 0 to 1 gigabyte, they would charge me, suppose this is $15. And so they would actually charge me. If I used no data, they would charge me $15. If I used up to and including 1 gigabyte, they would charge me $15. But as soon as I used a hair more, a kilobyte more, 1.01 gigabytes, my cost jumped up to $30. It was at 1 gigabyte, it was not 15. Oh, sorry, it was not 30, so that's why there's an open circle. But anything above one got me a charge of $30 up to, the second gigabyte, and so on. It would just keep jumping by $15. And so this is a graph that applied to me and my phone bill back when I was with Xfinity Mobile. All right, so just a little bit there on functions, domain, and range. Let me take a look at the other ones that we have. We have three more graphs. I'll do one more just to give one more example. Yeah, let's go ahead and take a look at problem number or the left graph here. And then we'll end the video and move on to the next one. So, first, is this a function? If you say no, you have to be able to show me a vertical line that crosses more than once. Well, there's one right there. So this is not a function. We'll say no. Okay. The domain. What's the domain of this graph? Well, to me, it looks like, let's see here. What color did I use? Purple for domain. So for domain, what are the x values that show up? Well, I see an x value of 1 here. And then the x values go to the right from there, and it looks like forever to the right. So if I were to map it onto the x-axis, it's 1 and forever to the right. And then we also have an x value of -1. And if we want to go, it doesn't really matter if we go down or up because right now when we're talking about domain, we're talking about just in the horizontal direction. I also move to the left. Okay, to the left forever. And so that would be to negative infinity. So my domain is negative infinity to -1. We do include that -1 because there is a point there that has the value of -1 as its x value, -1, 0, union 1 to infinity. Mhm. The union symbol just means or. So if you're asking what are the values, what are the input values, or what are the um, x values on this graph, well, they are either in the set from negative infinity to -1, or they reside in the set 1 to infinity. So that union symbol is needed to represent the word or. All right, what is the range? What is the set of y values that show up here? Well, let's see. This function, in terms of y values, it looks like it goes down forever just by the way that this thing is sloped. It's not really like, it doesn't look like it's leveling off towards, some value like -4 or something. It keeps going in the downward direction forever. And then it also goes in the upward direction forever. So if we graph that along the y-axis, it's going down forever and up forever. And so that is going to be negative infinity to positive infinity. All right, so you can try the, yeah, actually, you can try the other two and see if you get those right. You can pause the video. Maybe I can write the answer here really quickly, but I won't go into as much detail in the explanation. So pause the video, write your answers, and then you can check to see if you're understanding. All right. So, is it a function? Yes. There is, if you say no, show me the vertical line where it crosses more than once. And it has to be a vertical line. I had one student who was doing like slanted lines. No, the vertical line test, you got to use a vertical line. There is no vertical line that would cross more than once. The domain, it looks like it goes basically to the left forever and to the right forever, but there is this gap in the middle. That is a vertical asymptote. So the domain will be negative infinity to 0, union 0 to infinity. We don't include 0 because of that vertical asymptote. This function never takes on the value 0. The range, what, oops, what y values does this function take on? Well, it looks like the y values decrease towards 0. If you look at this closely, yeah, it does drop below 1. It looks like they are decreasing towards 0, but it does look like there's some sort of asymptotic behavior here. So we'll never actually reach the value 0. And then they go up to infinity. So I've kind of messed up the colors I was using. But it goes like this towards infinity, goes down towards 0, but doesn't actually reach 0. So I'll put an open circle there. And then it also goes in the negative infinite direction, also goes towards 0 from the negative side, but doesn't actually reach 0. So our range is actually going to be the exact same thing as the domain. That sometimes happen. It's not always, but there we go. And then the last one, is this a function? The only weird point here is, oops, is this x equals 0. I think it's pretty clear that everywhere else besides x equals 0, oops, besides x equals 0, the function crosses just once. But here at x equals 0, we're going to say this is a function. Yes, because if you were to look very closely, it this function is moving to the right, and then there is a moment where it kind of just goes vertical, but then it starts moving to the right again. So it's moving to the right and up, and then there's a moment there at 0, 0 where it kind of stops moving to the right, but then immediately after that, it does move to the right. Um, yeah, and so it's continuously moving to the right uh, for all x values. So a vertical line will never cross more than one point at a time. Okay, so uh, this is a function then. We'll say yes. What's the domain? Well, the domain is a set of x values. The x values that show up are, we can tell by the arrows, since it points to the right, this is always going to go in the x direction, to the right forever, to the left forever. The domain is all real numbers, negative infinity to positive infinity, sometimes written as this r here, but that is all real numbers. And then finally, the range. What is the range? Hopefully you did this one on your own to try it on your own. If you haven't, pause it because I kind of want to see if you saw this. Let's delete what we have here. The range. It's very subtle, but there are asymptotes, it looks like here. Look at the difference between this graph, this arrow here, how it's leveling off. It's going close to horizontal. That indicates that it is increasing towards that y value of 3, but never actually reaching it. Whereas this arrow over here, you can see it's a very steep angle. That means it is increasing. It is continuing to increase in the y direction, uh, not approaching a single y value. But there is a horizontal asymptote here as well. At least that's what it looks like to me. I mean, some of these are kind of up to debate a little bit, but if I was to give you the function y equals let's say 2 to the x, which we'll study later in this class, it looks something like this. You could say, oh, well, actually, your graph looks like it crosses the x-axis. Well, no, this function never takes on the value of 0. It approaches 0 on the left-hand side, but never actually reaches the value 0. Even though it looks like maybe it does, no, but once we know that the function is y equals 2 to the x, we know that there is a horizontal asymptote here at y equals 0 that never gets crossed. Okay, so the range then is going to be, well, it never reaches the value of negative 3. It does have y values for basically any y value from -3 to +3. So that's our range. All right, I hope you enjoyed that video. Make sure to leave a like on the video. Subscribe to the channel if you want to get notified of our other videos, and I'll see you in the next video.